Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another video of chem-solve. Today we are gonna solve paper 5070 variant 11. This is May June 2025 multiple choice. So let's start the paper. Okay. So the first question says four gases are listed: methane, ammonia, carbon dioxide and nitrogen. We have to determine the order of their rate of diffusion at room temperature and pressure. Okay, so for that, basically we need to understand that a rate of diffusion is inversely proportional to molar mass. It's mean higher the rate of diffusion, or you can say higher the molar mass, slowest is the rate of diffusion, and vice versa. So let's calculate the molar masses of the given gases. For methane, carbon is 12 and hydrogen is 1, and there are 4 hydrogens, so it will make 16. For ammonia, nitrogen is 14 and hydrogen is 1, and there are 3 hydrogen here, so it will make 17. And for carbon dioxide, carbon is 12 and oxygen is 16, and there are 2 oxygen, so we will multiply 16 with 2 and it will make 44. For nitrogen, it is 14 and there are 2 nitrogen here, so we will multiply it with 2 and it will make 28. So from this discussion, we came to know that methane has the lowest molar mass, so it would have the fastest rate of diffusion, while carbon dioxide has the highest molar mass, so it would be diffuse slowest. So the option will be C. Next question. Sodium is added to water and a chemical reaction occurs. Hydrogen and aqueous sodium hydroxide are produced. So let's write down the equation first. 2Na plus 2H2O. It produces sodium hydroxide and hydrogen. Okay. So, which row describe the reactant and the product in the reaction? So, I will look at the first column, reactant and the product that are element. So, for the option A, it is hydrogen, and for B, it is hydrogen and sodium. Aqueous sodium hydroxide, obviously not. So, this isn't the correct option. Sodium and water. Water is not a element, it's a compound. So, this option is incorrect as well. So I have to compete between A and B, and I think B is the right option because sodium is also an element. Okay, so reactant and the product that are compound, water and sodium. We just have discussed that sodium is an element, so it's not a compound. So for sure the option is B. So let's move to the next question. question number 3. An atom of element X is shown. Okay, so according to the key, the shaded one are the electron, the lightly shaded one are the proton, and unshaded one are the neutrons. Which element is X? Beryllium, boron, carbon, and magnesium. Okay, so we know that the identity of an element is its atomic number. Let's write here. It has 4 electron and it has 1, 2, 3, 4 protons, and it has 1, 2, 3, 4, 5 neutron. So it is something that has atomic number of 4 because the number of the proton are 4 here, and the mass number of 9 because you know mass number is the sum of proton plus neutron, and here it makes 5 plus 4 9. So just look at the periodic table and you will come to know that this is beryllium. Okay, let's move to the next question. Which definition of the isotope is correct? Okay, so isotopes, just look at the definition of the isotope by ourselves. Isotopes are the atom of the same element. They are the atoms of the same element. So option A is saying different elements, so wrong. Option B is saying different elements, obviously wrong. So we just have to compete between C and D. Atoms of the same element which have same proton and electron and different neutron. So option C is saying different number of electron. No, same number of electron. So this is not the correct option. So the correct option is this option. Atom of the same element that have different number of the neutrons. So D is the correct option here. Let's move to the next one. A pure sample of the element X has a relative atomic mass of 51.8. So we are provided with the atomic mass that is 51.8. The sample consists of 3 isotopes. Okay, the table shows the relative masses and the percentage abundances of the 2 of the isotopes. What is the relative mass of the third isotope? So we have to use the same formula to find out the relative abundance or the relative mass, for example. Okay, so the formula is AR, atomic mass, is equal to relative mass of the first isotope multiplied by the percentage abundance of that isotope plus relative mass of the second isotope multiplied by the percentage abundance of that isotope, and so on, divided by 100. So the first isotope is 50 by mass and its abundance is 40. So I will multiply 50 with 40. For the next isotope, it is 55. The mass is 55 and the abundance is 20. And for the third one, I have to find out the mass, the relative mass. I have to find out the relative mass. So I will suppose this is X, for example. And what would be its abundance then? Abundance is 100%. So this is 40 plus 20, so it makes 60. 100 minus 60, it will be 40. So relative abundance would be 40 here, and everything will be divided with 100. So let's solve it. I will replace the AR here with the exact AR that is being provided, and it is 51.8. As you can see in the question, it is 51.8. So I will solve it. This 100 will be multiplied with the 51.8. So 5180, and then I will solve rest of the things. It will make 3100 plus 40x, and we are gonna find out x here. So 5180 minus 3100, it will make 2080. You can use your calculator for this calculation, and that is 40x, and eventually x would be 40x. So x would be 2080 divided by 40, and using calculator the answer is 52. So here the answer is 52. That's B. Okay. Let's move to the next question. Magnesium reacts with oxygen to form magnesium oxide. Which row is correct? Structure of magnesium, structure of oxygen, and Mg positive 2 and O minus 2. Okay. So magnesium is a metal. So magnesium is giant metallic lattice. Oxygen is a covalent molecule, so we can say it is simple molecule. Alright. Mg positive 2 is positively charged, so it is a cation. And O minus 2 is negatively charged, and it is an anion. So just look at the options. Option C is the correct option here, right? Okay, ji. So next question. Which statement about a solid calcium chloride is correct? Okay. Calcium chloride is basically an ionic compound. It's an ionic compound. So before looking at the options, just look some of the characteristics of the ionic compound that we already know. So ionic compounds are soluble in water. Ionic compound can't conduct electricity. in solid form. But in molten and in aqueous form, they are the good conductor. They have high melting point and boiling point, and they have giant ionic lattice. Okay, so option A says it conduct electricity. Okay, it is solid. Okay, and we just have discussed that a solid can't conduct electricity. Solid can't conduct electricity. So this option is not correct. This is the wrong one. It has low melting point. So we just discussed it has high melting point. So this is also an incorrect option. It has an ionic lattice structure. Yes, this option is correct. So it is insoluble water. Obviously not. It is soluble in water. Okay. Question number 8. Which description of the metallic bonding is correct? Okay, metallic bonding is basically the bonding between positively charged metal ion and delocalized electrons. So this is our concept about metallic bonding. According to the option, it's saying electrostatic attraction between negative ions. No, not negative ions, between electrons. C of electrons. Electrostatic attraction between negative ions in a lattice and sea of proton. No. The electrostatic attraction between positive ion and negative ions. No. The electrostatic attraction between positive ions. Yes. In the lattice and sea of electrons. Yes. So our correct option would be D here. Okay, ji. Next. The ion Ca positive 2 and PO4 negative 3 combine to form an ionic compound. What is the formula of the compound? Okay, this is very easy question. We can easily solve it. So the first one is Ca positive 2 and PO4 minus 3. Okay, whenever we make the compound, so their charges are just swap like this. So resultantly, it would be Ca3 PO4 twice. Okay. So from this discussion, we can conclude that D is the right option. Question number 10. Magnesium react with aqueous copper sulfate to form copper and aqueous magnesium sulfate. What is the correct equation for this reaction? Okay. So magnesium is reacting with copper sulfate. Option B is incorrect because here the formula of the copper sulfate is incorrect. D is also incorrect because of the formula of the copper sulfate. The formula of the copper sulfate is CuSO4. So these two options are being excluded. Okay, so now we have to compete between option A and option C. And in option C, the formula of the magnesium sulfate is also incorrect. The correct formula of the magnesium sulfate is MgSO4. So our right option would be option A. Okay, question number 11. An organic compound has the molar mass of 88. What is the molecular formula of this compound? Okay, so for that, obviously, we have to calculate the molar masses. For the option A, C10, so we will multiply 12, the AR of the carbon, with 10, and then hydrogen is 1, it will be multiplied with 20, and oxygen is 16. We will add all of them, and the answer is 156. So obviously this is not the option. C5, so we will multiply 12 with 5, and for hydrogen we will multiply 1 with 10, and lastly we will add 16, that is the AR of the oxygen. It will make 86. So again it's a wrong option. For C, carbon is 12, so we will multiply it with 4. Hydrogen is 1, we will multiply it with 8, and oxygen is 16, and we will multiply it with 2. It will be 88. So C is the correct option. Okay, so let's move to the next question, question number 12. 10 cm cube of the hydrogen gas is mixed with 8 cm cube of the chlorine gas. Okay, so hydrogen is 10 here, and chlorine is X. We don't know what is its exact volume, and it will produce hydrogen chloride. Okay, so according to the question, the total volume of the gas at the end of the reaction is 40 cm cube. All right. All the measurement are at the room temperature and pressure. What is the value of the X? Okay. So first thing we need to understand that there is a ratio of 1:1 between hydrogen and chlorine, and 1:2 between hydrogen and hydrochloric acid. Okay. So let's make it easy. If a hydrogen is 10 cm cube here, chlorine should also be 10 cm cube because 1:1. But it is X. Only 10 cm cube of that X has reacted. So if I suppose that X plus 10, this 10 is basically the volume of the hydrogen, is total 40 according to my question statement. So X would be 40 minus 10, it will be 30. Its mean chlorine was 30 cm cube initially, only 10 cm cube of the chlorine reacted, alright, and 20 cm cube of the chlorine left behind. So 20 cm cube is left behind from here, and according to the 1:2, 20 cm cube of the hydrogen chloride gas is formed here. So 20 will make 40 cm cube. So here our answer would be C. X is 30 cm cube. And lastly, I explained that how does it make 40 cm cube at the end of the reaction. I hope it makes sense to you. Okay, so next question is from the mole calculations. 100 cm cube of the aqueous potassium hydroxide with a concentration of 1 mole per dm cube react with excess dilute sulfuric acid. Okay, so we are provided with the balanced chemical equation. 3.48 gram of the pure anhydrous potassium sulfate is produced. What is the percentage yield of the potassium sulfate? Okay, in mole series I have explained already these type of questions. You can watch that video if you didn't understand that. And we have discussed in that video that 3.48 would be actually the actual yield. Okay, this is the actual yield. The other name for the actual yield is the practical yield or the experimental yield. So we have to calculate the theoretical yield from the data. Okay, so let's calculate moles of the potassium hydroxide because we are provided data for that. So moles of KOH. So we are provided with the volume. Here's the volume and we are provided with the concentration. So obviously the formula we are gonna use here is concentration is equal to number of mole over volume in dm cube. So I will use that formula to calculate number of mole. I will multiply concentration with the volume. Concentration is 1, volume is 100, but we have to divide it with 1000 in order to calculate it into dm cube, and it will be 0.1 mole. Okay, now let's make a ratio between KOH and K2SO4. KOH and K2SO4. So you can see from the balanced chemical equation that KOH is 2 as you can see and K2SO4 is 1. So if KOH is 0.1, sorry, it will be here. If KOH will be 0.1, then K2SO4 would be half of that. So 0.1 multiplied by 1 divided by 2 and it would be 0.05. So these are the moles of the K2SO4 that we have calculated here, 0.05 moles. But obviously we need to calculate its mass. So for that we will multiply the moles with the molar mass of K2SO4, and the molar mass of the K2SO4 is 174. By multiplying them we will get the mass, and that is 8.7 grams. This mass is our theoretical yield. So by using the formula, percentage yield is equal to actual yield over theoretical yield. Actual yield is 3.48. Theoretical yield we just have calculated and it is 8.7. All multiply with 100 to convert it into percentage. Just solve it and you will get the answer. The answer would be 40%. Now let's move towards the next question. Which statement about electrolysis is correct? Okay. Negative anions move towards the positive cathode. Okay. Before that, we need to understand that anions are actually the negatively charged particles and cations are the positively charged particles. And cathode is negatively charged electrode and anode is positively charged electrode. So from this discussion you can get an idea that opposite will attract towards each other. So that's why anions will anions, these are the basically negatively charged. So anions will move towards the anode and cations will move towards cathode. So according to the first option, negative anions move towards positive cathode. Cathode is not positively charged. So this option is incorrect. Negative cations are not negative. So this option is also incorrect. Positive anions are not positive. So this option is also incorrect. Positive cations move towards negative cathode. Yes, positive cation move towards negative cathode. So this option is correct. Okay, next question. The diagram shows an electrolysis experiment using inert electrode. So in the right hand side of the beaker, we are given the electrolyte dilute sulfuric acid, and on the left hand side of the beaker, we are provided with aqueous copper sulfate electrolyte. Okay, and both are with the inert electrode. So just write down our own equations and on ions. Copper sulfate. Copper sulfate will have copper positive 2 ions and SO4 minus 2 ions. And it is aqueous, so it will have the water in it as well. So water has H positive and OH negative. Okay, so as the electrodes are inerts, so copper positive 2 will form copper at cathode, and OH negative will form oxygen at anode. So what would be left here? We will be left with hydrogen and sulfate here. Okay. So next option, dilute sulfuric acid. So dilute sulfuric acid would have H positive and SO4 minus 2 sulfate ions, and obviously it is dilute, so it would have water as well. So hydrogen and hydroxyl ion. Okay, so hydrogen will make hydrogen gas at cathode, and OH negative will form oxygen at anode. So in this way, here we will be left with again hydrogen and sulfate ions. Okay. So on right hand side we are left with hydrogen and sulfate ion. So we can say that the concentration would be more acidic here, and similarly here in this case the concentration would be more acidic here. Now look at our options. Which row shows what happens to the concentration of the electrolyte in the L and M, our beaker on the left and the right hand side, as electrolysis proceed? So we just have discussed that on both sides of the beakers, the concentration changes and it becomes more acidic in fact. So what would be the option then? If the concentration changes, then we have to choose the cross. So an option with both the cross is here. So A is the right option. Which row is correct for a chemical reaction in which delta H is negative? Okay, so if delta H is negative, then obviously it is an exothermic reaction. So obviously A is not our option and D is not our option. We have to compete between B and C. Okay, and we also know that energy absorb in bond breaking and is released in bond making or in bond forming. So option C says energy of the bonds broken is greater. No, energy of the bond broken should be less, and energy during the formation of the bond that is being released, it should be more in order to make a reaction exothermic. So the option would be B here. Okay, let's move to the next question. Question number 17. It says the diagram shows a apparatus used to investigate two different reactions that produces gases. Okay, so we have taken 5 grams of the solid X and it is being dissolved in 100 cm cube of 1 mole per dm cube of the HCl. And the experiment are the reactant of the experiment are mixed and the mass of the flask plus content for each experiment is recorded by every 30 seconds. A graph of the mass against the time is being drawn here. Okay, so we can see 4 options with the different graphs. In experiment number 1, solid is calcium carbonate, and when it will react with HCl, obviously it will produce carbon dioxide gas. And in experiment number 2, the solid is magnesium, and when it will react with the hydrochloric acid, it will produce hydrogen gas. Okay, so let's write down our equation first. In the first experiment, when calcium carbonate is reacting with HCl, it is producing CaCl2 plus water and carbon dioxide. Okay, this reaction would be a bit slower. and here a greater loss of mass. Why? Because carbon dioxide is being released here and it is a heavier gas. Okay, and for the next experiment, experiment number 2, when magnesium react with HCl, it will produce MgCl2 and hydrogen gas. This reaction is a bit faster because magnesium is more reactive, and there would be a small loss in mass due to hydrogen, because hydrogen is a lighter gas. So you can see experiment number the option A and B are incorrect. Why? Because both of them are increasing the content of the flask. The mass of the flask plus content is being increased here. While we know that if a gas is being produced, then it escapes from the content and the mass should decrease. While in these two experiments, the mass is increasing, so these are not our options. We have to compete between C and D. Okay, so as there are less loss of the mass in the experiment number 2, so there would be more content of the flask there. It's mean less loss in the mass, so mass of the content plus the flask will be more. And this is shown in the option C. So option C should be the correct option here. I hope you may understand this. Okay, question number 18. In a closed flask, gas Q and R reaches dynamic equilibrium. Equation is being written here, and delta H is positive. So it's mean it is an endothermic reaction. Which change will move the equilibrium to the right? Okay, adding a catalyst. Obviously not, because catalyst has no effect on the rate of the position of the equilibrium. Okay, option B, decreasing temperature. As you know, this is endothermic reaction, so if we will decrease the temperature, the reaction will move towards, the equilibrium will move towards the left hand side, so this is also incorrect. Okay, option C, increasing pressure. Increasing pressure will favor that side of the equation in which there would be less number of moles. So less number of moles are on the left hand side, so the reaction will move towards the left hand side. So it is also incorrect because we have to move the reaction towards right. Increasing the volume of the flask. Okay, according to the Boyle's law, we know that volume and pressure are inversely proportional to each other. If we will increase the volume, the pressure will decrease. And if the pressure will decrease, the equilibrium will move to that side of the equation with the more number of the moles, and more number of moles obviously are here on the right hand side. So this is our correct option. Okay, 19. Which row shows the typical condition used for the conversion of the sulfur dioxide to sulfur trioxide in the contact process? Obviously, option A and B are incorrect. Why? Because they are using iron as a catalyst, and iron is the catalyst of the Haber process, not the contact process. So we have to compete between option C and D. Okay, and we know that the pressure of the contact process is 2 atm, but here we are provided with the pressure in the kilopascal, so we have to convert atm into pascal and then pascal into kilopascal later on. So 1 atmosphere is equal to 1 into 10 raised to power 5 pascal. So 2 atm will be 2 multiplied by 1 into 10 raised to power 5, mean 2 into 10 raised to power 5 pascal. Okay, now 1 kilopascal is equal to 1000 pascal. So 2 into 10 raised to power 5 pascal would be how many kilopascal? We will divide it with 1000, and in this way we will get the answer 200 kilopascal. So right option will be D here. Okay. Question number 20. The pH of the dilute ethanoic acid is measured. The equation for the partial dissociation of the ethanoic acid is shown. Aqueous sodium ethanoate is being added here. Okay, so when we add aqueous sodium ethanoate, it would have CH3, C double negative ion, and obviously Na positive ion. So it's mean we are adding more CH3, C double O negative ions here. What is the initial pH of the dilute ethanoic acid, and how does it changes after the addition of the aqueous sodium ethanoate? So let's talk about the initial pH of the weak acid. Ethanoic acid is a weak acid, and you know acids have the pH less than 7. So it's mean option C and D are incorrect. We have to compete between option A and B. Okay. So now look at the change in the pH after the aqueous sodium ethanoate is being added. Okay, so when we add sodium ethanoate in it, so the concentration of the ethanoate ion will increase, and when the concentration of the ethanoate ion will increase, then according to the dynamic equilibrium, it will move towards right hand side of the equation. Okay, so when it will move towards the right hand side of the left hand side of the equation, it will move here towards the product, towards the left hand side of the equation. So when it will move towards the left hand side of the equation, then the concentration of hydrogen ion will decrease, and we know that pH is inversely proportional to hydrogen ion concentration. When hydrogen ion concentration decreases, pH increases. And here, because the reaction moved towards this side, so there would be less H positive ion. So I can say that the concentration of the H positive ion decreases. And a decrease in the H positive concentration will increase the pH. So our correct option would be A. will be A. Okay, so option will be A here.